Hi guys, Vanakkam. Welcome to my channel. Today I'm going to discuss a topic called joins. It's a very common technique that you will end up using at your workplace or even for your personal projects. So let's just get started. So joins, right? So why do we need a join? So suppose when you're working in a company or a project, whatever, you'll have some databases, right? And databases will have tables. So you can have 2 tables, 3 tables, or n number of tables. So there might be a case where you want to join uh, a table with another table. So suppose there are 2 tables, A and B, and you want like the entities of these 2 tables at one place, and then sort of perform your analysis or run your queries or whatever. So that is the case when you use a join. And how do you join? Like suppose you have table A and table B, there has to be a common element to both tables where you perform the join. So you need a common element which I'll probably get into a descriptor in the next video, primary key, foreign key. I'll get into all that. That's the case. So to join, you need sort of a key which is common to both. So let me just share my screen and sort of give you an example to what I was trying to communicate. So here you have a products table and customers table, right? And you sort of want like these 2 tables to be appended at one place and then perform your queries. So to do that, you need to have like a common element, as I said, to both, which in this case is ID. And then you can, after you've identified your common element, you can perform your joins. And joins are of various types, like inner join, left join, right join, outer join. So for this video, I'm going to discuss about inner join and left join, which is pretty much kind of same as the right join. So inner join, right? Let me just highlight a figure that will sort of tell what I want to say. So suppose you have 2 tables, table A and table B. What inner join will do, it will join on the common element, which is like the ID, which is the ID should be common to both. So wherever for table A and table B, wherever there are common IDs, it will join to both. So so this is the case that will happen for in the case of inner join. So let's just get back to my table right now. So inner join, right? What I said. So for the product table, you have ID and price. For the customers, you have ID and rating. So in this case, your priority is just to get a match, just to get a join wherever there is a match on the IDs. So you can see 2345, 2345 in both the tables are common. So wherever there is a match, 2345 IDs will come and you will get the tables combined or joined. So you have the price and ratings from both the tables here, right? So that is the case in the case of that is the case for inner join, where you just care about the IDs. You don't care about getting nulls or whatever. So that is the case when you use inner join. Another join is a left join, which is pretty much similar to a right join. So in the case of a left join, you want the entities in the left table to be there at any cost. You don't care about if I'm getting nulls and all in the right table. You want the entities, all the entities in the left table to be there. So here my left table is considering left is products and customers is right. So I want to perform a left join, and because I want all the entities in the products table. So what will happen first is all the IDs which are there in my products table will get sort of appended here, and then you'll get the corresponding prices also. So what happens here is, you can see, so 1 2 3 4 5, all the IDs from products table and all the prices are there, because for this case my priority is I want my first all the entities in my first table to be there for sure at any cost. I don't care if I don't get a corresponding rating, but I want all the elements in my products table. So what happens is, so see, for one, for the products table, you have ID1 and price, right? But that ID1 is not there in the customers table. So for that reason, you'll have a null value here, because there is no one in the customers table. You'll get a null value. But as you go for table 2, for ID2, there is a price. That's what we want. And there is a rating as well. So you have the rating 7. Similarly, for ID3, you have a price. It'll get appended immediately. And for ID3, you have a rating as well. So rating 6. Similarly, for ID4, you have the price. That's what you want at the first place. And you have the rating as well. So wherever there is no match in the second table, you'll get a null. And similar, like if this customers was to the right, you'll probably use a right join. So I'll probably now, just to make it more clear, I'll sort of share a question and try to solve it on Leetcode, which sort of highlights this concept at a very nice granularity that'll easy for you. This was the figure for like a left join where you want everything which is there in A, plus this common part wherever there is a match in B, right? So let's just get to this top travelers question on Leetcode, which I'll try to solve here and show it to you all. So yeah, let's see what the question says. So here you have two tables, users and rights, right? So these are the two tables. Users, you have ID and name. For rights, you have ID, user ID, and distance. So what you need is write an SQL query to report the distance traveled by each user, right? And let's have a look at our like the output table. You need the name and you need the travel distance. So as I said, why do you need a join? When you want when you want to combine the tables and then get some information or perform some analysis, right? So you can see like if here they're asking to report the distance traveled by each user. So normally what you could do is you could just perform a group by on user ID and then get the sum of distance for each user ID. But here in this case, you need the names as well, right? That is why you need to sort of join these two tables and then perform an analysis. That's why you need a join. So let me just try and highlight what I was trying to say. So I'll perform my join operation first. So I'll take the first table from users. I'll try to join rights, right? So I'll just perform an inner join first to just highlight and show what I was trying to say. So you write a join statement first. So from users, so from my first table, join the second table. And as I said, you need your identifier, right, to join the tables. So here in this case, the identifier is ID. So ID is the primary key to the users table, and user ID is the foreign key to the users table. So this is the entity which is common to both ID and user ID, right? So you'll be joining on this common entity. So how do you do it? So you first write your from join, and then you provide that entity on which you want to join. So from users join rights on. So on you'll be now you'll need to provide the reference for the table names followed by the unique ID that you want to join on. So from users join rights on users dot ID, right? And then you want to perform the join on rights dot user ID. So that's it. So what happens here is now you have sort of joined, you have users and rights, all these tables at one place. You have everything at one place, right? And then since you need to perform like a group by, because you need the sum of distance for each user ID. So we'll perform a group by here, group by user underscore ID. And let's see and now what you need is now because we have joined the tables, we have all our entities, we have ID, name, ID, user ID, distance at one common place. And now, as I said, we're going to perform our analysis of whatever you want. So in this case, we want the names and the traveled distance. So select name, comma, the sum of distance, right? That's why you need the sum for each ID. So let's see what this gives here. So let's look at our output, right? So I'll just minimize myself here and try to show you what the problem is here. So what we needed is we have in our output, we have Alice, like it's not ordered. I'll just do that now. Order by, so that it's clear for you. And then try to show what I wanted to. So it's running, and yes. So now we have all our travel distances and the names, what we see here, but there is a change in our the output we got versus the expected output. So here you can see Donald, right? Donald is not there in our expected output. So yeah, this is what I was trying to investigate and trying to show, why do we need a left join versus why do we need an inner join? Because we have performed an inner join, we are only going to get a name. We are only going to get the names wherever there is a common ID to both the tables, right? So here it would have joined these IDs whichever IDs are common, it would have joined on those IDs. But in this case, as you see the output, our priority here is to get all the names at any cost. We don't care about if we get nulls or not. We don't care about that. We want, even though Donald, right? Donald has probably like he doesn't have any representation in this table, right? Meaning he hasn't traveled any distance, but we want Donald's name to be there in this table. So that is why we want all the entities of my left table to be sacred and preserved. So that is why we'll be using a left join here, which will give us all the entities from the users table. So let me just change it to a left join, and then you can see our output will sort of tally to what is required. So let's see what this gives us here. So right, you see the difference now. Previously, when we performed the inner join, we were not getting Donald because it just matched on these common IDs, which were common to this. But Donald was not common to this table, so we didn't get Donald. But our priority is we want all the IDs at any cost. So now you can see we have got Donald here. This is what was expected. It's returning a null because because the sum it returns a 0 normally. But if you perform a if null condition, you can just sort that out, and we will get what we want. And I'll just name it to travel distance. And then we'll have the exact output as was expected. So let's see what we got. So yeah, you can see. So now we have what exactly what was expected. We have like there is no error, like Donald is probably not showing up, but this is what the expected output was. So as I showed, when you use like a left join, you sort of get you want to preserve all the elements in the left table at any cost. You don't care if there is like if there is if a null value comes for the other table. You just want all the entities in the users table. So this is what I wanted to highlight in this video, that when to use a left join, when to use a right join. So in case my rights, I probably wanted all the suppose distances, then I would probably use a right join because it's just the order rights is on the right. That's why I use a right join. It's kind of similar to the left join. So yeah, like if you would have understood, like now, I hope you would be clear when to use a left join versus a right join, or when to use an inner join. So yeah, that's it for this video. Probably in my next video, I'll try to highlight when to use like a self join, and probably discuss more on primary keys and foreign keys. So thank you for being there for this video. I'll hope to see you in the next. Bye.